Hi everyone, Ms. Stillman here. I'm here to go over homework 7 with you. This is for Mr. Krieger and Ms. Stillman's classes. So take a look at problem number 1. You'll see that the sides are split perfectly, and that means because the sides are parallel and the sides are split perfectly, this is the side splitter theorem. Look at how that parallel line makes a perfect fraction bar, and that's how we set up the equation. Same with problem 2, parallel lines, split the sides on either side. There you have it, perfect fraction bar, side splitter theorem. Oh, and again, you can pause the video at any time. Here's number 3. Number 3 was very important to know. If you're using the 10 and the 20, you couldn't use the 20 in your proportion. You had to add it together to get the full side of the triangle. 10 plus 20 is that 30. And there's one of the many proportions you could have done. 10 over 30 equals x over 33. You could have instead said, let's say 33 over x equals 30 over 10. Make sure you have the same answer as us, and also make sure that when you cross multiply you get 30 times x. Okay, here's question number 4. Make sure you have the sides fully added up. Take a look at that 6 plus 2. You don't use the 2 in the proportion. Okay, now this would have been on your back page. I used a key over here from last year, and it's all on the bottom right there. Make sure you're looking for VC. Okay, make sure it is using the side splitter theorem. 5 over 7 equals 10 over x. And now let's go to the back. Last 2 questions. Number 6 also has parallel sides. So when you put the numbers on it, make sure you add them together, because even though it's looks like it could be side splitter, there's nothing on AB or BC. There's only numbers on the parallel side, so it is not a side splitter, it's just similar triangles. Now the last question, please make sure you read it and underline keywords. You want to make sure that you draw a triangle for the tree. It's a right triangle. And then Bobby walked 30 feet along the way, and then his or her shadow stopped right at the corner there, and the shadows lined up. So that 30 is just a walking distance, and you use it to subtract. You do the whole shadow of 40 minus the 30 to get the 10. And now here's another example of how you might see it without the 30 even being there. Now you have a tree of X tall, Bobby of 5 tall, shadow on the bottom 40, shadow for Bobby 10, and there's your proportion. If you have any questions, please reach out to me or Mr. Krieger to let us know what you need a little more clarification on. Bye for now.